Okay, everyone. So today we have somebody, and the audio was cutting out a bit, but what we're doing is we're designing a search recommendation system. And we're working through a coding interview, and this is just the first part. So I'm just gonna delete, or let's not work, or let me enter it here. But we're building a search recommendation system, and pretty much we're gonna be given an array of strings, products, like this, and a string search word. Like we're gonna be searching for the word mouse, like that. And then pretty much as each character is being typed, we need to suggest products with the same common prefix. So for example, when they searched M, pretty much all of these have a M. So we just need to, so we could return all of these in our search results, but we only want to return the top three results, and we want those results to be sorted in lexicographical order. So like mobile, money pot, monitor, these are like the the first three in lexicographical order, so we return that. And pretty much as we start searching, like MOU, it's gonna filter down the search results. So your approach is gonna be. Could you explain your approach again?
Yeah, so my first approach I thought of was just to sort the list right away. So we get this list here, and then we could kind of use two pointers to keep track of our bounds of valid words. And then since it's already sorted, we would just print out the first three from the left pointer, or if the right pointer is closer than three, then we just print out what's inside that range. And this would be n log n for the sorting. And then for each letter, uh, it'd be an extra about O of n because we would only eliminate or like check each word, I think once.
Like what if it had like a long prefix like that? The words are big.
It would be like for all the M's, then this would still be in our range. And then same with the O. When we hit the N, then it would shorten down to this. Like we would check this word for every M, but only that word and then we'd check this one on the right as well for every M to make sure the right pointer is still there. And then same for the O. And then once we got to the N, then we would check the N on this left one. It wouldn't be there, so we'd move it in one. And we would check for the N in money pot, and it would be there. And then for mouse head, we would check just for the N. It wouldn't be there. For mouse, we check just the N. It wouldn't be there. And for monitor, we check the N, and it would be there. So, like, we wouldn't have to
But like,
compare the
okay,
entire
how are
prefix.
we moving? Yeah, how are we moving this prefix? Like, pretend it was all the M's, like M star, and
Mhm.
for like, it does this for a lot, and then all of a sudden we're like MO. Like, how do we move it to?
Like what I'm saying is we don't have to recompare the whole prefix. We can, since we know that the first whatever letters already match in this range, we can just check this one index, check if it matches. So it would be like an O of one check instead of like an O of n check for the prefix. This is just one solution. We could also obviously use a trie. But I'm not sure because that there's a setup cost involved with that. I'm trying to think if it would be worth it because for try, we'd probably do the same thing. We would sort it in advance and then insert every word into the try. And then at each node, normally we would just have like is end and next, but we could add a third member variable that would just be all the words with this prefix. And then since we insert it in lexicographically order already, since we pre-sort like the products, we would just return the first three from that node. So the try is also another valid solution. I'm not sure how much that would speed it up though, because it's still n log n for the sorting, and then that would still be then for inserting each word, that would be like O of M, like for the characters in each word. And then, yeah, I don't know. Those are two approaches. I'm trying to think which one I think would be better.
Yeah, I mean, both seem to work.
Hmm. There might, in my first approach I mentioned too, there might be, you might be able to cut it down to like a binary search ish algorithm. I'm trying to think because we're sorting it.
I pretend like the next one
But
is O, and then we have to like there's a lot in between. Then we're gonna have to
mhm.
increment this. Like, pretend this
Yeah,
one.
yeah.
It might be less efficient than your second approach.
Hmm. What I'm saying is though is like yeah, we would have to increment the pointers one by one, but that's still like O of n, right? Because we're passing over each word once. Like we're once that word's cut off, we're never revisiting that word again. But yeah, I think I might like the try solution better, to be honest. Okay, so how would the try solution work? We pre-sort, we insert it, and then we just have the extra member variable. So then at each like quote unquote query, like at each letter, we just move down the try and then return the first three in that list. That's going to be more coding, I think, to set up the try, but I think that just logically makes more sense, and like the code will look cleaner. I think
Yeah.
that might be the better approach.
Okay, let's go. Let's go with the try then.
All right. Okay, so we're going to need a try node, first of all, which will have, what will a try node have? Try node needs to have, so the next array, next, which is all the letters, so 26. And then it needs to have, there's end. And then constructor normally, is this how it works? Yeah, because it links, yeah, it links to the next node. So in our actual try, we will have our try node, which will be our root, which will just be a null pointer, because, and then to point to our first letter, we'll use the next thing. Yeah, which will be that. So then our constructor. Yeah. So then what we're going to need is get, I think, right, is that one? Trying to get our C. So, and what we'll do is we will just return actually yes. So, next at I equal corner. Try node. Oh, that's why this needs to be try node pointers. Okay. So there's a constructor, and then we will return next at C minus A. Yeah, and then put Then we want to put something in. What we need to do is we just need to do next and C minus A. Try node. Okay, so we have get, put, then we'll do bool is end, just return is end. Definition, and then we should also have, I think we need make end void, make end, which just sets is end equal true. What method am I missing here? We need get, put, is end, make end. Oh no. True. Okay. And then in our actual try, what we will need is to be able to insert words. So void insert, we'll take string word, and then, yeah, so root. Okay, yeah. Try node P.
Did I ever fold you before or no? Like give you a question that you couldn't solve or no?
Yeah, there was the one 2
Is it the
interviews
validate
ago.
binary search or binary node?
Yeah, the binary
Okay.
search. I kind of fumbled that one. I might fumble this one. I kind of am not remembering try off the top of my head. I think I can get it, but it's gonna take me longer than I want it to. I already know. Yeah, okay, so yeah, we need this try. And then to insert a word, we're going to need a pointer, which initially will be at our root. And then for every character in our word, we will just insert it if it doesn't exist. I think that's the method I'm missing in try node. I think I need to check exists. Yeah. Bool exists car C. Return get C not equal no pointer. Okay. So if not p dot exist C, then we will need to insert it. So we'll do p dot put C, and then either way we'll want to move down our links. So we'll do p needs to go to equal p dot get C. This like moves us down our try chain, and then that should be it. Oh, and then in the last node, actually, we'll need to do p make end. And then, yeah. So this is our insert, but normally you would do like search prefix or search, but what method do we actually need for this problem? Basically, for this problem, we shouldn't be researching every time. We can basically use our last thing. So let me think what I actually want to do here. I think what I want to do is I want to make a, okay, so what I need every time is to return 3 names. So it'll be, this will be a vector of strings. And I think what I want to do is I want to make a search from function where I can take in a try node and continue searching from that one. So I don't recompute the things already done. For example, if we've already done M and O, we don't need to research that prefix. We just want to start on the N. So I can pass in my node I got from O and search from there. So,
well, when you're given the search string, like when you're given the search
Yeah.
string, right? You're it's not gonna change. Like we're not gonna be querying it multiple times. Like you're gonna start off.
Oh, true. So I can just start from the start and build up my answer the entire time. Yeah, that's easier. Yeah, so this will be a vector of vectors of strings. Yeah, I'm just gonna search a word. String word. So at each letter, I am basically just going to, what do I want to do? Yeah, so similar to that, we need to get our pointer, go to root, and then I'll just let me copy this so we won't delete what I don't need. Yeah, so each letter, if it doesn't exist, then I guess we just break. But if it does exist, then we are going to want to do, let's also make our answer here. Std vector, std string, answer, and we'll do and so push back. And what do we want to push back? We want to push back. We'll call it p.query. We actually need to implement this method. I haven't made it yet, but basically go back up to try node. What we want to have at each try node, as I mentioned in my very initial explanation, is we're going to want to have a vector of strings, which will be, what do we call this? Products, I guess. Products, and since we're inserting in sorted order, we can assume these would already be here. So what are we doing? I think what I'm going to want to do here is call put every time. Or no. What I'm going to want to do here is I'll make another method, add product, which we throw the word into. Okay, so where are these methods going to go? Yeah, so I'll do void add product, std string product, and all we're going to do here is products push back product, and then we'll add query, which will std vector std string query, and what we're going to want to do here is return the first three elements of this. So for I equals 0, I less than the minimum of 3 and product dot size.
It's 3U.
Yeah, that just means I'm sad. I think it should fix a type error, but I don't know. Yeah, less than that plus I res dot push back product set I. What's going wrong here? No matching function called to min. Requires 3 arguments. What? I'll get back to that in a second. But query, yeah, I should return the 3. And then we add each product. Okay, so you'll push back p query, get C. And I think we should also have another check here. If P is equal to no pointer, and then we should also break. And then we do not need that. Yeah, so for character and word, if it does not exist, we break. And then, yeah. Actually, this should not be no pointer. There, and then there, and then this is not in the right bracket. Okay, so where's the error come from?
No return statement in the function or mismatch types. But those are just, they're not actually issues, right?
What is this min one? What? Yeah, so I less than the minimum of 3 or products dot size. Yeah, well, oh, there we go. And then, and then return res. Okay, just running. I guess
Okay,
we should probably go
walk
through
me through line by
steps.
line.
All right, starting from where?
Starting from the main function.
The main function.
Or sorry, like the function, the outside function where it's searching, and then drill in deeper and deeper.
Oh, this one. Okay, so we initialize our answer array. We get our pointer to our root, and then for every character in Word, we check if this character exists. So if this character doesn't exist, this means that there is no words at all in our original project list that match this prefix, so we can just break and return what we currently have. Otherwise, we will push back p.query. So if we go to p.query, what that does is it grabs the first 3, or if there's less than 3, then that many products that are in this node. And the products array or vector is an already sorted list of all products that had this prefix, and we put them in there when we did our insertions. So it will return that.
The minimum of 3 and the size. What if there's not any, or what if there's 2 or 1? Or I guess
so then it will return 2 or 1.
Okay. And then when you add,
and then we would get the next node.
Wait, go back to the. Let's go back to. Okay, you're running the query.
Yes.
Well, let's talk about inserting first. Just make sure that the try is correct.
Mm-hmm. Okay, so on insertion, whenever we're inserting a new word, we start off at the root.
Mm-hmm.
And basically, if this character doesn't already exist, so if we haven't had a word with this prefix already, we need to put it there. Basically, what put does is it just creates a try node, like with that link in there. And then these or needs to be switched. Yeah, puts it there. And then get moves us like down to that character. So let's say we just inserted an M. When we do get, we're moving on to that try node that like actually has the M in it now.
Yeah.
And then we would add product. So in our products list at that M node, this product is now in that list.
Let's look at the add product, p.add product.
Yeah.
Okay. Push back.
So it just pushes back the product.
Okay.
Mm-hmm. I don't think we actually need the make end or is end things for this problem, but we'll take that later if we have the time. Yeah. Yeah, and then it just does that for each letter. So it'll continue down, adding the letter if we haven't already made a node for that prefix, and then continue down into that node, and then adding our word to the product list for that prefix, so that when we query it, we can get it.
Okay, let's look at your try. So the try has a vector. It just has one next. Where's the list of next? Okay, so list of
List of them.
next.
So that'll be like for each
Yep.
character.
Yep. We say if
Yeah.
it's an end. We say if it's a product. Okay, so for each one, we're kind of listing out the products.
Mm-hmm.
And we add product. Okay. Get. So when we're getting, we get C minus A. Yep. Exist. Is the end. Okay. Do we need this part of is the end or make the end?
No, I don't end up calling this at all.
It's all good.
I wrote it just when I was making the node because I think you normally have that in the try.
Okay,
But
let's write some test cases.
okay. So yeah, we'll go to main. Let's bring down this test case you sent in originally, which is this. Okay. Okay, I'm down at the like main function right now. Okay, so products and search word. So what we're gonna want to do is create a try, and then to vector system products. Okay, so try, and then for let's just do for P in products. Try. Yeah, so for auto, P in products, try dot insert P. Actually, we need to sort this first. Sort products dot begin, products dot end, and then yeah, this should be min sorted by default, I believe, but I'll double check that after. Try dot insert, and then we should just be able to call try dot search. So say auto ands equal to try dot search mouse, and then or mouse. Okay, it looks like to me I'm missing one thing. What am I missing here? Yeah, so what's going wrong here? Do you see the terminal output? Like the first four correct, but we're missing the last.
Yeah.
What is it? Yeah, the last. What is it supposed to be? Mouse and mouse pad. Yeah. So, okay, so let's see. Search. So for every character in Word, we check if it exists. Yeah. And if it doesn't, then we break. But and we push back the query, which looks right. Then we move to the next letter. And yeah. What's going wrong?
It's just not putting the last one in, right?
Yeah. But I'm trying to see why. Will this fix it or not? No. No. Huh. Okay, if this if that does not exist, we put it there. Turn get C does not equal any pointer. Okay, and then equal to new try node. Yeah, that should be fine. So then
Well, it is at the end, right? The mouse.
yeah.
So when you're at the E, there's nothing under it. So it's I think it's returning, but it's returning an empty.
Hmm.
Your very last row, it's actually working, but it's returning empty. Because it's at the E, and E has no children, I think.
No, it doesn't look like it. Wait, let's see. Like, mouse. Okay, so it is going through all of them. Should be querying.
Or see out the response here too of the each query.
Mm-hmm. Yeah, let me go into query. Let's see. So, yeah, so, okay.
See, like the very last one, or your M is not returning anything.
What? The M is not. Fixed it.
Nice. Cool. Like right on time. We're like 4 minutes left till the end.
Mm-hmm.
How was that?
Yeah, that was a good problem.
Yeah.
Again, I didn't like how much debugging I have to do. I really don't like when my code doesn't work the first time.
Good job though. You just pulled out the able to implement the try right on the spot.
Mm-hmm. Yeah, I was not sure if I was going to be able to do that.
Yeah, probably just labeled this like making a candidate like do a try right on the spot. I don't even know. But cool.
Mm-hmm.
I have to
Is that
take
how
on
you're
the.
supposed to solve it? Is it
Yeah,
supposed to be
I
you
think
sort it into a try?
people have done it the way you did as well. Honestly, I didn't look at what's the fastest try or which one's the fastest runtime complexity.
Mm-hmm.
I do the try. Okay, the binary search. That's the first solution. Try. It looked like the try one is way more efficient from what I see.
Okay.
Yeah, because like
Yeah, I thought of try right away, but I was like, oh, maybe I can avoid not writing a try here. But then the more I thought about the first one, I was like, yeah, I think we're just gonna have to make a try here.
there's a binary search example, but then there's also just a try example. Yeah,
Hmm.
people just do the try.
Yeah, I
I
think the
like to do
try
the
is
try for
most
that
fun.
one.
Yeah,
Cool. Thanks for implementing that. I'll catch you again.
yeah, of course.
All
Thanks
right,
for interviewing me.
no problem, man. Peace.
Peace.
All right, Chad. I have to take a quick break. My eyes is burning.